Welcome. In this tutorial, I'll be teaching you how to use the function Lerp. It's a way where you can transition smoothly between 2 points, rotation, and basically any two values that you want to change by. So to do this is very simple. What we need to do is open a new scene and create a new script called Lerp and an object that we want to move using the Lerp. So let me create a simple scene quickly. Right now I've just finished setting up a scene in Unity. It's just a cube on top of a simple plane, and what I want it to do is smoothly transition between this point here and this point there with the press of a button. So by moving it to the left side of the plane, we can see that its current position is x equals -4, and I want it to be x equals +4, which is the other side corresponding to the plane. So left, right, left, right. Let's just move that back and check our scene view. This is what we'll see when we start the game. I've just changed the camera view a bit so that the camera looks down at the scene when we start the game. Next, what we want to do is open your script named Lerp, and this is what you should see. I'll start off by explaining what I want to do and each step we take. So the first step is we're gonna move the cube, so I'll show you an example on how to do that and the effects, and then I'll show you how to smooth the process of moving that cube. So to move a cube using code, we'll simply get an input. There's many ways to do it, but I like to do it when I press down space. So just do a quick input dot get key down, and in this I'll set the transform, the current position of the cube, equal to new vector 3, and I'll set the position. If you remember what it was before, it was 3, 1, and 0. Finishing it off with a semicolon, saving it, and going back into Unity. And when we run the game, you see that if we press the spacebar down, it automatically zaps to the location we set it to be. If you got a bit confused with what's going on here, I'll be leaving a description and also a card in this video to link you to the videos I've made before. So the whole entire point of this video is to teach you how to smooth out the process in between the movements. So how would you do that instead? And this is where the Lerp comes in. If you just look at this code simply, it is taking the position and then setting it to a new position. So the current position of the cube is -4, 1, 0, and when you run the game, let me do this, and when you run the game and press space, you see that the x gets set to 1410, which is exactly what we want it to be. Okay, so now the entire point of this video was to smooth the transitioning between 2 points. So this is where everything happens in this one line of code. And a Lerp function basically takes in a starting position and an end position to transform. So this is our start position, and basically this is our target position. If you think about it, this is our current position, we're making it equal to our target position. That's how we're changing with the press of a button. What we can do is set this to a vector 3, which is a variable, then we can pass it in to our Lerp function we can use later. So we'll simply just cut this, and in front of our, above our start method, what we'll do is name a new vector 3, so a vector 3, and we'll name it target pose. And in void start, we'll simply set target pose equal to the vector we set before. So basically, this vector 3 named target pose is basically this entire line of code. So saved in this is 4, 1, and 0. And now when we press our button down, we're setting the position to a smooth transitioning to this position. So what we want to do is vector 3 dot, this is where the function comes in, Lerp, and we'll do a bracket, and if we hover over the function, you can see it takes in 2 vectors, a starting vector and a ending vector, a and b, and it interpolates between the two and in the value which it travels at. So the first value we want to put in is our current position, so transform dot position. Transform dot position, that's the starting position, and The target position is what we made before, so target pose right here. We've chosen that, and our last variable, which is the float, we simply can set it to time dot delta time, and we can times it by a speed, so we can modify it however we want. Saving that, and in the front we'll name a public field called speed and set it to an int. We can make also a default value of 5. If we save this and go back to Unity, then it compile, and if we run, and when we press down our spacebar, you'll see that the cube slowly moves in increments towards the destination. That might not be what you thought is gonna happen, because you thought we were gonna with the press of a button, it will go from the left hand side straight smoothly to the right hand side. But that's not happening, because in our code there's an error, if you can spot it right now. It's in the input.get key down line right here, where it is only running this code when the key is getting pressed down, and that's only a fraction of a second. So what we want to do is get rid of this down. So as long as we hold space, this line of code runs. And if we save this, go back to Unity and run, you'll see that the cube does exactly what we want. It just zooms to the other side like smoothly and in the transition that you expected. And with the speed, you can change it however we want. I set it to 5 as the default, but you can modify it to 1, so it goes more slowly. So if we hold space, you see that, and it slows in the end. And you can change the speed to whatever you want really. So if you want a really fast transition, you can set it to 30. That may be a bit overkill, but yep, that's a bit overkill, but you can still see the transitioning of the cube moving to that position instead of just teleporting. And looking back in our code, the one line you're probably confused about is probably time.delta time. You see people using it a lot, but you don't really know what it is. I'm planning to make a video on it in the future, so keep an eye out. But basically, this is what's keeping the cube traveling at a stable speed across the plane. So if I get rid of this and run the code again, you'll see the changes immediately. It's big and clear. So if I can actually go back into Unity, run the game, and when I press space, the cube just zaps there. So that's the difference time.delta time makes in simple form. So if we put time.delta time back into our code, and then what it will do is again create a satisfying transition between the 2 points. So if we run, well, right now it's way too fast, but if we set this to a 5, you'll see that satisfying transition. So like that. And with that as a base, you can create a very simple system right here. This code is not optimized at all. I'm just purely showing you this for the purpose of showcase. So you can basically set 2 destination points and saving them to a vector 3 like I showed you, and pass in 1 in for left arrow and 1 in for right arrow. And you can create like a simple movement between 2 points. So for example, a shooting game you might want to do, and where you can just move between the 2 points, and when you let go, the cube just stops. You won't just stop in the middle or zap back to its original position. It will stay where you stop pressing your arrow. So, and then you can fine tune the speed that we set before to maybe a 5, maybe a 2 or 3, and you can create like a suitable movement for your game where you can start shooting enemies, and where when you move around, you're trying to, the bullet is always shooting at stuff, dodging obstacles, and you can create all sorts of indie games using this method. For a quick example of indie game on the market that's probably using this is one of those games where it is using a cannon to shoot balls in the map with numbers, and the more balls touch the numbered balls, the number gets decreased, and the objective of the game is to get rid of all the numbered balls on the map. Something like I'm showing on the screen right now, as you can see. This is only a simple introduction to the Lerp function. I'm hoping to make more videos on how to use Lerp, for example in rotation and in all sorts of all sorts of other stuff. So thank you for watching. I hope you've enjoyed and learned something, and this video was helpful to you. And bye.